It was 28. Let me bring up the...
I mean, the one I was asking is actually on the take-home quiz. I don't know if I'll ask questions.
Yeah, you can ask.
Okay.
Yeah, that's fine. I don't have it in front of me, so you'll have to...
So it's, I have it here.
Is it easy to say or here? Just okay, go ahead.
It's solve.
Uh-huh.
It's 2 plus 3.
2 plus 3.
Parentheses 4x minus 1.
Close parentheses.
Equals 6. Open parentheses 2x minus 5. Close parentheses plus 29.
All right. Is that when you were confused also?
Yeah.
Okay, so look, I'm always open to answering questions. I mean, just because it's a take-home quiz doesn't mean I'm not open to, addressing the question. And you should have a question on this one if you don't recall what to do in this special situation. Because I didn't talk about this in class. So please be aware, just because math is just like this. I can do problems in class, but you may get something at home that's slightly different than what you've seen. I can't show you an example of everything. All right, so let's try this. I'm going to try and solve for x, and I'm going to remove the parentheses first. Is that what you did first? Remove the parentheses, like distribute? So you distributed a 3 through here. And did you get 2 plus 12x minus 3? Number 8? Is that what it is? 8? Okay, number 8. That's what you got when you distributed? We good up to that point? Okay, then you distribute the 6 through, and you get 12x minus 30 plus 29. And what was your name again? Tatiana. Tatiana? So what did you do next? Because I want to take you to where you got confused on it.
I combined the 2 minus 3, so I got 12x minus 1.
Okay.
And then I just filled out the rest of it.
So you put these two together, and you got 12x minus 1? Okay. And did you continue at this point?
I got 12x minus 30 equals 12x minus 30.
Oh, so you took the 29 to the other side? Okay, you could have done that. Remember we talked about different roads to the same destination? I want to stick with what you did. So you put those two together, you got -1, then 12x minus 30 plus 29. If I were doing this, I would have just put those together, but that's not what you did. You subtracted 30, or 29, and you got 12x minus 30 equals 12x minus 30. Okay, and did you continue? You just looked at that and said, what the hell's going on, right? Okay, so anybody know how to do this? What to do?
You add 30 and then divide the 12.
You can add 30 to both sides?
Yeah, and divide the 12.
All right, that's fair. And what would you be left with if you did that? 12x equals 12x, and then what? Divide 12 on both sides. That's legal, okay. And you get x equals x.
X equals 1. Oh, wait.
Yeah.
X equals x, right?
I got the same thing and I was like, oh, that doesn't make sense.
Yeah, that doesn't make sense. Anyone know how to handle this? Are you just being quiet? You're just being quiet? What's going on here?
Well, I didn't know, I just put that solution.
You put no solution, okay. We're on the right track now. So look, with linear equations, remember this is a review concept, so hopefully you've seen this before. With any linear equation, there are 3 possible things that could happen. You could have one answer, you could have no answer, and you can have an infinite number of answers. Those are the 3 possibilities. Everything that I did in class, you had one answer, one answer, one answer. But on this, were one of these on the homework also?
Yes.
Yeah, this should have popped up and then someone should have come in and asked questions. This is what I expect. If you're doing your homework, you're going to run into an issue. So the question is, which case is this? Well, let me try something here. How about I just subtract x from both sides? That would be like me trying to get x on both sides of the equation. I would try and remove x from this side. But when I do this, what happens? 0 over here equals 0 over here. Is this true? Is 0 equal to 0? Yes. So if we go backwards, what we're saying is that this equation is true, but this equation is the same as this equation is the same as this equation, backwards all the way up. And so what we're saying is that this equation is true when? It's true when this equation is true. And this equation is true always, right? Is 0 equal to 0? I hope so, right? So the end result here is if you get something at the end that is correct all the time, 0 is 0, that means that any x that you ever choose will make this equation true. That means there's an infinite number of answers. All right? Let's just try. Somebody give me an x and make it a nice x. Don't give me some crazy x. Someone give me a 2. Okay, let me try 2. I'm going to write what the answer is in a second. I'm going to write it the way I would want to see it on a test. But first, let me just try. Let's let x be 2, and let's rewrite the entire thing. 2 plus 3, 4 times 2 minus 1 equals 6. 2 times 2 minus 5 plus 29. So I'm going to do this kind of quick. 4 times 2, 8 minus 1, 7. 7 times 3, 21 plus 2, 23. The left side's 23. Let's see what the right side is. 4 take away 5, negative 1, times 6, negative 6 plus 29, 23. It's the same, right? Now, give me another value of x. Let's go with 0. It's easy to plug in 0. Let's try 0. All right, so if we plug in 0, it would be 2 plus 3. Let's go faster. 0 here would just give you what? Negative 1? You all okay with that? Equals 6, and then let's plug in a 0 here. That's gone, so just minus 5, or negative 5. And then plus 29. Let's see what happens here. This is negative 3, right? Negative 3 plus 2? Negative 1. Over here, negative 30 plus 29. Negative 1. So 0 is an answer, right? 2 is an answer, and it turns out that any number you ever pick will work. How do we know that every number that we pick will work? Because when we did all our work, we got to this thing at the end that said 0 is 0. And since this is always true, that means every x works. Does that make sense? So how would I want you to write the answer to this? You would just say infinite solutions. Another way you could write the answer is like this. And some of you may have seen this, some of you may not. If you haven't, don't worry about it. And that's what we call interval notation. And that's saying, how do I say everything on a number line? If you have everything this direction, everything this direction, we say, if you go that way forever, that's what we call negative infinity. And if you go this way forever, that's positive infinity. And we just put a set of parentheses around it. This means everything, all numbers. There's even another thing you could write that I would be okay with. A third answer. You could write all real numbers. Have y'all seen that before? I'm just giving you all these different things so that if you've seen some of these, you're like, oh yeah, I've seen that before. Another answer you could write, and this is probably less likely that you've seen that, is a double struck R. Okay, double struck R is representative of all real numbers. So just any of those, okay? All right. I want to do something. I want to put this problem back up here. I want to start it over. I'm going to change something though. I'm going to change this 29 to a 10. All right? And we're going to work through the whole thing again. So we distribute the 3 through, we distribute the 6 through. We get 2 plus 12x minus 3 equals 12x minus 30 plus 10. Do y'all agree? Now, what I normally do is collect like terms on one side, so I would go 2 minus 3 and give me that minus 1. And I would collect these two together. and that would give me a minus 20. So I would get 12x minus 20. Now at this point, you want to try and get all your x's to one side. So how about we get rid of these x's, and what are we going to do that? Subtract 12x. And, uh-oh, what do we get? Here is gone, and what are we left with? Negative 1 equals negative 20. Is this true? I hope not, right? Negative 1 is not negative 20. This is your third case that could happen. What do you think this means? No solution. This means that there is no way you can ever come up with an x, ever, that's going to make this true. So we put no solution. And you can write that no solution. And there is another way to write it. Like this is what we call interval notation, interval notation. A way to write no solution kind of in this notation is to use this. I don't know if you've ever seen that before, but that is what we call the empty set. It's the set of nothing. It's a basket that has nothing in it. So you're saying, hey, your answers are in here, take a look, and there's nothing in there. Okay, that's what that is, the empty set. Does that clarify everything? Okay, good. If nobody would have asked me anything, I would have been concerned, because then I would have been like, is anyone doing their homework? Because this should have happened, all right? All right. Any other questions? Did anybody print out the take-home quiz? Anyone print it out? Do you have it with you? Can I see it real quick?
Number 26.
Just want to take a look to see. Well, that printed weird.
Yeah, it did.
Okay. Yeah, that didn't print quite right. Okay. You'll be okay, right? You'll look at it online? I mean, because online it looks right, right?
Yeah.
Okay. Okay. Yes?
Number 26 on the homework.
On the homework, which would have been, where is it? Wait a minute. 20. What page was it? Do you know?
Yeah, 12.
12? All right. Negative 4x equals 5 parentheses 1 minus x over 6. All right. And what was your name, sir?
Javier.
Javier. I want to follow what you did just to, that way we can get to where you might have had the trouble. So what did you do here?
Well, I did the 5.
Multiply the 5 through the parentheses first? Okay, that's fine. Okay, everyone agree with that? And then what?
That's where I stopped. But
That's where you're hung
I
up?
think this is you multiply by 6, correct?
Yes. Now this is not the only thing you could do, but yeah, that's what I would do. I would try and clear the fraction out. So I don't like this denominator. Since it's an equation, I can multiply both sides of the equation by anything I want. I'm going to multiply by 6. And when I say that, I mean 6 over 1, right? That's what I mean? 6 over 1. And whatever I do this side, I have to do also to the other side. So I'm going to write 6 over 1 over here. And I'm just going to remember that negative 4x is the same as negative 4x over 1. That way I can see it's a fraction times a fraction. And then I just multiply straight across. On the left side of the equation, I should just get negative 24x. That's what I get when I multiply straight across. And then over 1, just write it like that. On the right side, though, those 6's cancel, which is why I did it, right? I don't necessarily need to distribute the 6 through here, because then I don't get the cancellation. So this is kind of the whole point of coming in with 6 was to make that happen. So what is left on the right side? 5 minus 5x. And then at this point, it's more like a linear equation that you're used to. What would you do at this point? You would add 5x? Okay. Add 5x. add 5x, and these go away, and that gives you negative 19x, and then equals 5, and then divide by negative 19, and you're done. Yes?
I have the same, a question in the same homework, but question 21.
21. X minus 5x over 2 plus 7. Plus 7 equals x over 4. All right. So may I ask what you did?
I didn't really try to.
You just kind of looked at it and freaked
Yeah, I
out?
was like, I was gonna ask.
Okay, that's fine. Anybody else have a recommendation? Yes?
I times both sides by 4.
You multiply both sides by 4. So you don't like fractions. I don't like fractions. Well, I do like fractions, but I'll act like I don't like fractions. Okay, so you don't like this, but it's an equation, so you realize that if you multiply both sides by the LCD, least common denominator, fractions will go away. So you came in with 4, because isn't 4 a multiple of both of these? Yes? So when you multiply the left side by 4, you must put a 4 out here in parentheses around the entire left side because there are 3 terms. On the right side, I don't need to put parentheses because this is a single term, so I can just put 4. I do write it as a fraction on the right side just because I'm multiplying it times a fraction on the right side, so I want to make sure everything lines up. These are gone. So the right side's x, that's clean. And then the left side, this just passes through to each one. So we'll get 4x, right? All right, this is the one that you have to be careful with. This times this. So what's 4 times negative 5x over 2? You can look at that. You can do it like that. Negative 20x, you could look at that as negative 20x. That's multiplying across the top, and the bottom would be 2. And that would be negative 10x, right? Or if you don't like that, you could have just done, 2 goes in 2 once, 2 goes in 4 twice, and do it that way. It just depends on you and what you're comfortable with. But at the end, everyone should be able to get to negative 10x right there. And see, there's no more fraction. And then finally, 4 times positive 7, which is 28. Is that better now? See, and now at this point, you can start putting things together and moving things around. You should be able to get it. All right. Well, let's get into today's material. We actually need to finish up what we were talking about last time. We were doing polynomials, and we stopped. And I hadn't had an opportunity to look at some of these, I guess, word problems, if you want to call them word problems. So this first one, it gives you a triangle, and it tells you something about each of these sides. That this one is 3x squared minus 4x plus 9. That this side is 2x squared plus 4x minus 10. And the bottom side is 5x plus 3. And it asks you to write a polynomial that represents the perimeter of this triangle. So what is the perimeter of an object? What's the perimeter? It's just the sum of all of the sides, the lengths of all of the sides. So all we need to do here is, start at this point, measure this side, then add to that this side, then add to that this side. Those lengths added together gives us the perimeter. So I'm going to write down that the perimeter, I'll call it P, is equal to this, which is 2x squared plus 4x minus 10, plus the other side, 3x squared minus 4x plus 9, and then plus the last side, which is 5x plus 3. And then just combine all your like terms together. Put all your x squareds together, all your x's together, all your numbers together. And that's the answer. That's all we want. So how many x squareds will I have? I have 2x squareds here, and I have 3x squareds here. So when I add those together, 5. We have 5x squareds. How many x terms do I have? 4x. I take away 4x, so it's gone, but then I add 5x. So I should just have 5x, right? And then in terms of just the numbers, I have negative 10 plus 9, which would be negative 1, and then plus 3, so 2. And that's it. We have come up with a polynomial that represents the perimeter of this object. If someone actually told me what x was, I would just be able to spit out what the perimeter was right away, just by plugging it right into that. Questions? So perimeter is the measurement of the distance around an object. Look at number 2. Find a polynomial that expresses the area of the shaded figure below. Yeah, let's see here. I'm going to draw it first. They tell you that this is 2x minus 5, and that this is 2x minus 5. So that's a square, isn't it? Because it's the same length. And then they've got this little box on the inside. And then the shaded stuff is everything outside that box. And they want to know the area of the shaded part. Now we all have to know or remember that the area of a rectangle, like if someone gives you a rectangle, we call this length and we call this maybe width, then the area is length times width, right? Now if it happens to be a square, then of course it's just the length and the width are the same, so it would just be, it's still thing, it's that side squared. So this is the more general formula. If I take this right here, this length, 2x minus 5, and I multiply it times that length, that would give me the area of the entire thing, right? Including the inside? I don't want the inside. So you have to take that inside out, right? Remove the inside. And we need to know something about the dimensions of the inside in order to do this. Do we know the dimensions of this? It's in the word problem. The white square is x by x. So this side right here is x from here to here, and this side from here to here is x also. So the area of this red part, the area is x squared, isn't it? X times x. So if I want the area of the shaded region, what I need to do is find the area of the whole thing and then subtract from it the area of the red thing. And that's what I'm going to write down. So the area total will be the area of the entire thing, which we said was this times itself, right? I'm going to put squared. Minus the red part, which is x squared. Now that is a formula for the area. But let's try and simplify this. And what I mean by that is let's actually multiply 2x minus 5 times 2x minus 5, because that's part of what this section was about. So I'm going to say area is equal to 2x minus 5 times 2x minus 5. That's what it meant to square. And then I still have minus x squared. And then you do that thing of multiplying through. And we call this expanding the polynomial. You're going to do those 4 multiplications. This, you could use that FOIL thing if you like the FOIL thing. You can say that. So let me do it. 2x times 2x is 4x squared, right? 2x times negative 5, negative 10x. And then on the inside one, I'm going to have another one of those, right? Negative 10x again. And then when I do the negative 5 times negative 5, this last multiplication, I should get plus 25, because negative times negative is positive. Am I done? I still need the minus x squared, right? Just don't forget that thing is there. And now let's collect everything that's like terms together, and that will be our final answer. So we have 3x squareds. Because we had 4 of them, we took away 1 of them. Minus 20x plus 25. That's it. Any questions? Let's just look at number 3. Write the polynomial that represents the perimeter. So what are you going to do for number 3? Add all those together, right? You just want to add all the way around. So I won't do that. I'll let you do that yourself. Look at number 4. Write the polynomial that represents the total number of square feet for the floor plan below. This one I do want to see what you would do here. See, they give you this floor plan. Close enough. It's good enough, right? What's the area of the square, what's the polynomial that represents the total number of square feet for the floor plan? So square feet for the floor plan means that they want the area of the floor plan, which means you need to figure out what the area of this entire thing is. But that's a rectangle, right? So you just need length times width? Okay, so what is the length? What's the total length of this thing? It's this and this together, right? Add those two together. What's x plus 6 plus 24? X plus 30, right? Because all you're doing is you're adding 6 and 24 together. So this is really x plus 6 plus 24, which equals x plus 30. That's how long that side is. And this side, the entire length is x plus 12. And so to find the area, I multiply this side times this side. I have to have them in parentheses to do this. It's the entire side times the entire side, or the length times the width. So we have to do the expansion, where you multiply here, 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 here. You think you could do that okay? You should get x squared plus 42x plus 360. And that's it. That's the area in the square footage of that. Now, someone would have to tell you what x is, and then you could tell them exactly the square footage, but that's it. We good? All right, now we are going to move on to a new topic. And this is a pretty big shift in concepts. We're going to be talking about factoring. Factoring is the process of turning addition and subtraction into multiplication. That's what factoring is. So let me give you an example of factoring on a very basic level, all right? What if I said 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5? You could actually sit there and add that up, right? 5, how many times am I doing it? 2, 3, 4, 5, 6, 7, right? So I'm doing 7 5s together, which should add up to be what? 35, right? That should be 35. So I could do 5 plus 5 in my head 7 times, or I could realize that this is the same as 7 times 5, right? Multiplication is actually a way of writing addition, repeated addition. So what I want you to see is we have turned addition into multiplication, haven't we? Another way we could have done that, and this lies more in line with what we're about to talk about, is I could see that these all have something in common, right? What do these all have in common? It's kind of obvious, but they're all 5s, right? So I could say, all right, here's what they have in common. I could, what we call, factor out of 5, and then I could put a set of parentheses, and then I could ask myself how I could recreate each of these terms. So what would I have to multiply 5 by to get this 5 back? 1. And then I'd put a plus because there's a plus there. What would I have to multiply 5 by to get this 5 back? 1. And I would do that for every single one of those, right? And what's 1 plus 1 plus 1 plus 1 7 times? 7. That's just 7. And so you'd get back to this, wouldn't you? Okay, now this is very, very like primitive way of looking at factoring, but this is what factoring is about. It's taking something that's added or subtracted and somehow converting it to multiplication, which makes our lives a lot easier later when we're trying to do certain things with functions. So when it comes to factoring, there are a lot of different techniques to factoring. There's a lot of different things. And everyone has a different background in factoring in here. I don't know where everyone is in their factoring right now. I have no clue. How many of you feel good about your factoring? Okay, so like maybe 3 or 4 people, that's about it. That's pretty normal. Factoring is one of the weakest, I guess, the Achilles heel for most math students. Factoring is like this thing that people don't like. But it is definitely an Achilles heel. You can't do much math in this class or beyond if you can't factor. So it's one of the things you have to be able to do. This first section we're going to talk about right now is the most basic form of factoring that there is. There's a lot of different techniques to factor. This is the most basic one. And it's kind of like the analogy of you can't walk until you crawl, right? You have to crawl before you walk. This is crawling, all right? We have to be able to crawl. If we can't crawl, we won't be able to walk. So we just need to make sure right now everyone is comfortable with this idea of factoring by what's called using the Gcf, which stands for greatest common factor. Okay, so look, I realize this is Math 1314. I realize that coming to a math class is not the funnest thing in the world, but I'm seeing a little bit of falling asleep, and I'm seeing a little bit of people on their phones. All right? So let me remind you what the syllabus says. If you fall asleep, it costs you 10 points on your next exam. If you're on your phone, 10 points on your next exam, right? We clear, everyone? All right. If you're tired, just get up, walk around, walk outside, go up and down the stairs a few times, or just take a nap outside and come back later or something. Just don't fall asleep in here, please. Got it? All right. All right, greatest common factor is the first and most basic technique for factoring, and it's pretty much what I just did with that 5, where I noticed something that was in common, and then I kind of like pulled it out. So let's see how you handle these. And these, this first one, this is about as easy as it's ever going to get when it comes to factoring. But we need to be able to look at this and recognize that there's something we can do. Right now I have addition, right? 2 terms. I want to somehow turn that into multiplication. So with the Gcf method, what I'm looking for is the greatest thing, or the most, all right, that these 2 terms have in common. So I start by looking at numbers. What numbers do they have in common? Well, they both have a 6, right? Now I start looking at letters, variables. Do they have any variables in common? No, this has a y squared. This one doesn't even have a y. So the only thing that these both have in common, the greatest thing they do have in common, is a 6. So I just write this 6 here. So I'm going to put equals 6. Then I put a set of parentheses, and I allow myself enough space in here for two terms. And the reason I'm going to say 2 terms is because that's what I started with, right? 2. So I need enough space in here for 2 terms. And then I just ask myself a couple of questions. What do I multiply 6 by to get that? So what's missing? I have a 6. What do I not have? A y squared. So if I put a y squared here and I distribute, I would get back that first term. Now, what am I missing here? Yeah, I mean, you could say I don't need anything, right? 6 is here. I need a 6, right? I've got it, right? But you have to be able to distribute through to something to get a 6. So you have to realize that there's a 1 here, and you put plus 1. See, because the distribution has to happen to recreate this. If you just leave this off, then if you multiply, that's not this anymore. So you must have this plus 1. Okay? Do you see that we've turned it into multiplication? We have a multiplication here now. We're done. Next one. xy squared minus 3y squared. Factor using greatest common factor. So I'm going to start with numbers. And there is always a 1 sitting in front of everything, right? So is there a number that these both have in common? A 1. Anytime we see 1 as a common factor, we don't worry about it, right? We just ignore it. We're looking for something other than 1 that they would have in common. So number-wise, I don't care. There's nothing there. Okay? How about letters? This has an x. This one doesn't have an x, so they don't have an x in common. How about y squareds? We have y squared here and y squared there. Exactly. So that's part of my GCF. I put it on the outside. Anything else they have in common? That's it, right? We've looked at the numbers, the letters. We're done. So now I'm going to set parentheses here, enough space for 2 terms. And then I just try and figure out what I would multiply this by to get this. Another way of saying that is if you look at this, compared to this, what's missing? What's missing? An x. So I'll just need 1x here like that. And then here, I've got, I need to get negative 3y squared. I already have the y squared. I'm only missing the negative 3. So I just put negative 3 here. And then you can always check your work by just distributing, and you should get back this. And we're done. Box it up. We're done. All right. Let's look at the next one. I'm going to change the next one a little bit. All right. I'm just going to modify it slightly. I put a negative 3x squared instead of 3x squared. All right, we're going to try and factor this. So we look at it and we try and find something that they have in common. We start with some numbers. So what do y'all think?
3.
They both have a 3. These are both multiples of 3, right? Negative 3 is a multiple of 3. And 6 is a multiple of 3. So I can have a 3 as my GCF, part of my GCF. And then how about letters? X squared here and x here. So you have to do what they have in common. And the fact that this right here is x times x, that's what it means. This has 2 factors of x, this has 1 factor of x. You can only pull out what they have in common, which would be a single factor. They both have 1, right? They don't both have 2 though. So I'm going to have that 3 that I pulled out earlier that I said was part of my GCF. I'm going to have a single x factor, and then after that, what do I write? So parentheses, right? Enough space for how many terms? 2 terms, and now I start filling in those terms. So how are you going to turn a 3x into a negative 3x squared? What are you missing there? Negative x. Good. Negative x, negative times, or positive times negative is negative. And then the x and the x together would give us the x squared. And then how about over here? Plus 2? Plus 2. And that's it. Yes?
Could you possibly do negative x?
That's exactly what I was going to ask you. In fact, I was going to ask you, would this be correct? Let's look at that same exact problem. Could someone else have come in here and said, you know what? I'm going to use negative 3x instead. So the person who's doing it this way is saying, look, I see a negative 3 as a common factor. Are they okay to do this? Well, can you turn this back into this? You have a negative 3, got it. X, I need x squared, so I'm only missing what? X. So that should take care of that. What about this one, though? Negative 2. Now, if you multiply negative 3x times a negative 2, negative and negative multiply to be positive, you should get positive 6x. So this works also, doesn't it? Which means these are both correct. Which means with factoring, you can have slightly different versions that are equivalent. Now, these are different, right? This is positive 3x. You've got a negative on the x and a positive on the 2. Here you've got your negative 3x on the outside, but now look, it's switched. It's now positive here, and that's switched over, right? So both of those are correct. And for those of you who have done a lot of factoring, you probably know that sometimes this is better to use this one over this one. Just depends on the problem. All right, let's look at 4, because 4 looks pretty ugly. (16) x squared y squared minus 28x y squared plus 48, I'm changing the problem, x cubed y to the 5th. I put an x cubed in there. That doesn't have an x cubed in that one. Do y'all see where I changed it? Right there. All right. I want to factor this using Gcf. By the way, I told you factoring was a lot of different methods. The first step to factoring anything, ever, is this method. After you do this method, then there's a bunch of different things that could happen, but this is always the first thing that we do. So I look at this, let's look at numbers. Is there a number that is 16 is a multiple of something, 28 is also, 48 is also a multiple of that number. So is there something that divides into all of these? 4, is that the largest thing you can think of? 4? I think so. 4 is the largest multiple of those, or largest divisor of those. So 4, that sounds fine. And then x's, I need to have what they have in common. So I have 2 factors of x here, 1 factor of x here, 3 factors of x there. So how many can I pull out? 1. Just 1. It's the minimum number of factors that appears. So that, I should restate that. It's the maximum number of factors that appear in all of them. Yeah, because minimum would be nothing. You just don't pull anything out. Okay, how about y's? Y squared, right? They all have at least 2 factors of y. This one has 2 of them, 2 of them. This one has 5 of them. So you want what they have in common, which would be 2. And that's it, right? There's no other letters or numbers to deal with. I write a set of parentheses, and I leave myself enough room for how many terms? 3 this time. I have 1, 2, 3 terms. So I give myself enough room for 3 terms. And I try and recreate, from this, I try and recreate that one, then that one, then that one. So what are you going to have to multiply 4 by to get 16? 4. What are you going to have to multiply x by to get x squared? X. What are you going to have to multiply y squared by to get y squared? Nothing. 1, right? Put a 1 there. It's going to work. You don't need to put the 1 though, right? That's it. That's the first term. Now you need to create the second one. So what do you multiply 4 by to get negative 28? Negative 7, right? Negative 7? That will give you negative 28. Now, what do you multiply x by to get x? 1. You don't need anything, right? Right, to get this to be this? How about y squared to be y squared? Don't need anything. So the negative 7 should take care of everything for us. Then the last one. What do you multiply 4 by to create a positive 48? 12. So plus 12. Just remember, you have to have 3 terms, so you've got to have some addition or subtraction here. And then to turn x into x cubed, x squared, right? And finally, to turn y squared into y to the 5th, y cubed. That's it. That's factored. All right, why don't you take the next 3 or 4 minutes and you try and do number 25. Hopefully you can read it up there. Or it's not 25, sorry, I was reading the number in the front. Number 5. See if you can do that okay. I'm assuming you have it, yes? When you get your answer, raise your hand so I have an idea of how long this is taking everyone. Okay. Good. Let me see what you got. Which one is it? That one? 5x squared y cubed. What do you got? Okay, that's looking good. Yeah, that looks right. Yeah, that looks good. Yep. This right here, the 8, I think that should be at 13. Because 5 times negative 8 is like negative 40 or something, so negative 13. Yeah, that looks right. Mm-hmm. Okay. Yep. 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 Where are you at? Okay, I was looking at that one. I was like, oh. Yeah, that looks good. Hold on. X. Ah, you can pull more X's out. Look, see, you still have an X in all of them. X, X. This one has 3 factors of X, right? This one has 2, that one has 4 of them. So you could get another X to come out. You see that?
Yeah.
So pull an X, 5x squared y cubed out, and then you'll be there. So, yeah, you got to figure out how many x's do they have in common. So this is cubed, right? 3. This is 2 of them. This is 4 of them. So the most that appears in all of them is 2. So you put x squared there. How about with the y's? How many factors of y do we have here? How many here? How many here? 3? So that's the most you can get out is what they all have in common. So 3, right? 3 is the least that they all have in common. So put cubed, 5y cubed. And then what you have to do is figure out what to multiply through to get back these. So I'm just going to put the answer up here. I think it's 5x squared y cubed, right? And it's 5xy xy minus 13y squared, and then minus 16x squared. There it is. That's it right there. Okay. Yeah, no, well, we can't. This is actually an equation with 2 variables in it. It's Non-linear, very difficult to solve. Very difficult. All right, what's next? Your homework is what's next. So you can finish out this homework now. I think I told you just to do through 16, right? So now you can do part B on page 17. So page 17, part B. You can also do page 18, part C. And we still have 10 minutes. I want to at least talk about percentages. We won't get all the way through this. I'm just going to do the first few because they're very basic. We'll save all the word problems till next class. Most people are comfortable with the concept of a percentage because we hear it a lot, right? Every time you get a test back, they tell you, percentage, grade. So when we say percent, what we mean is this. X percent means X out of 100. That's what it means. Another way you could write this is X over 100, which will get us more into next class when we talk about what are called proportions. So for example, let's see. Let me count how many students there are here first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 26 students in here right now, okay? Looks like we have more girls than we have guys. So guys, raise your hands. Where are you? Okay, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 out of 26, right? We have 8, I'll say males, that sounds a little nicer. Males over, what, 26 total students? So what is the percentage of male students in this class? Well, we just divide, right? We divide. And so you get your calculator out and do this. 8 divided by 26, and you're going to get a decimal. And that decimal is approximately, I'm going to use an, excuse me, I'm going to use an equal sign that's squiggly, which means approximately, all right? 0.30, I'm going to stop at this, I'm going to round it. It was actually 0.307692308 on my calculator. I just went to the third decimal point and I said, I'm going to round this one. Look to the right of it, it was 6, so that meant round it up to 8. Now, what percentage of the students in this class are men? 30.8%. So what we need to remember about percentages is that if you have a decimal, to convert it to a percent, all you do is take the decimal point and move it to the right 2 places. Do you all remember ever seeing that? Okay, so move that to the right, we get 30.8%. That's the percentage of males in this class, all right, 30.8%. To get females, we would just do the fraction the other way, right? We would do what? How many females are there? 18. We do 18 over 26. Or we could just say if 30.8% are males, then the other percentage are females, so we could just take 100% and subtract. But the reason I'm showing you this is because percentages are used all the time, but the definition of a percentage is that it's out of 100. So if you write 30.8%, what you mean is 30.8 out of 100. So when we were looking at this class, there were only 26 students, right? There were only 26 students. When we say 30.8%, what we mean is that if this class were 100 students, 30.8 of them would be males. But see, if we use percentages, then we always can convert everything over to out of 100, so that it makes sense in our minds. If not, then if we didn't have a way to easily convert over, then I think I'm going to confuse you more if I continue to talk right now. We need a standard that we can all look at and all have a good visual idea of what it means. I think we all know what 10% looks like, what 50% looks like, what 80% looks like. All right, that's the definition. Now, the problems that we have up here are little small word problems where we want to find relationships between numbers. Just like we found a relationship between these numbers and we found a percentage, we want to do that with these little short problems. So, what percent of 200 is 21? What percent of 200 is 21? That's just a weird sentence. Do you agree that doesn't roll off the tongue very easy? What percent of 200 is 21? It just, what? What are they talking about? So there is a standard way that we are going to approach these word problems. We're always going to look at the word of. Anyone know what we do when we see the word of? We're going to look at that as where we're going to have our multiplication. I'm just going to put M-U-L-T. Anytime we see of, we start thinking, yeah, that means multiplication. Anytime we see the word is, we're going to be thinking equal sign. And then when we see the part of it that says like what, here in this case it's what percent, this is going to be our variable. In this case we'll use x. And so what we're going to do is we're going to take a word problem and we are going to convert it into an equation. So if I just rewrite this word problem using everything I had in red, I would write down what first? What percent? X. Okay, next thing I should write down, multiply times, right? Times. Next thing was 200. Then is 21. There it is. And this is a linear equation, isn't it? That's a linear equation. And we normally wouldn't write x times 200. We would write 200x instead, equals 21. And now solve that for x. So you would divide both sides by 200, right? Now you're going to need your calculators, all right, at this point. So go ahead and on your calculator, see I even brought mine. What are we doing? Clear. 21 divided by 200? 0.105. So x is equal to 0.105. Now, we have to just go back and think, is this our answer? Are we done? No, we're not, because what they wanted to know was what percent, right? Our answer needs to be a percent. Right now, it's a decimal. To convert a decimal over to percentage, we take the decimal point and move it 2 places to the right. So this will be 10.5%. Now, a good way to check to see if you did this right is to go back to the problem and replace this with your answer. Our answer was what? 10.5%? And read it to yourself and see if it makes any sense in your mind. 10.5% of 200 is 21. Does that make sense to you? 10% of 200 should be smaller than 200, shouldn't it? And 21 is definitely smaller. So if you were to come in here and you were to say something like, if you were to get like, I don't know, negative 40%, right? Then something's wrong. Something is off, right? All right, I'm running out of time.